There we go.
All right.
All right. I think we're good now.
Okay. What kind of problems do we have here?
Okay. So I just want to start out with completing the square problem.
Okay.
If you could make one up.
If I can make one up?
Yeah. I don't really have any homework. This is just some stuff that I wanted to practice.
Yeah, no, that's fine. Wow, making one up is what's tough. I could get my... it's much better if you can bring the problems to the session.
Okay.
Because there's lots of different completing the square degrees of difficulty.
Okay.
I can certainly make one up, but I'm not sure it's the kind that you're going over right now. I got It's always better if you bring it.
Okay. Just looking one up here.
Okay.
There's y equals negative 16x squared.
That's it?
Plus 96x plus 3.
All right. See, this is a much harder one than I would have made up. I would have made up a simple one. Do you understand the concept of completing the square?
Not entirely.
Okay. Tell me the instructions again on these questions. I can help you complete the square, but if we're going to do it, I want to start with an easier one than this.
Okay.
First of all, let's take this function here. Let me just take a very straightforward one. Okay. If I were to take that function and try to factor it, I wouldn't be able to. I also would not be able to, what I'm trying to do is put this into vertex format. Vertex format is this. Y equals a times x minus h squared plus k. In other words, if I can get this function into this kind of a format, then I will know precisely what h and k are, which is the vertex, which is the most important part of a quadratic. So when it's in this form here, I don't know where the vertex is. There's a couple of other formulas that one can apply, but one of the easier ways to figure out is to complete the square to put it into this format. So let me show you how to do that. First of all, what I'm going to separate are those two right there. You always put your x squared and your however many x in parentheses. So now I have this. And I'm rewriting it because I want to leave a little bit of room. Where I'm going to complete the square is inside those parentheses. Okay? Now, when you're completing the square, what's really, really, really important is to not change it when you go from one line to another. I have not changed it. There's line 1, there's line 2. Okay? Now, to complete the square, you take half of the coefficient of the x term and you square it and you add it. So what is half of the coefficient of the x term?
3.
Okay. Square that.
Oh. 9.
Okay, so I'm going to always, it's always adding, whether it's positive or negative, because when you square it, it always becomes positive. So I just added 9, okay? Now I've changed it. It's no longer the original equation 1. But what if I subtract 9? Like that. Now it's the same. It's no different. The difference is that because I completed the square, I can write this term as x plus 3 squared. That's the whole reason that you complete the square, is so that you can write it as a linear term squared. You will always be able to do that if you use the rules. In other words, if you take half of that coefficient and square it, then it will always be able to be written like this. What's the rest of it? Plus 1. Now, notice what format it's in. It's in perfect vertex format. Tell me where the vertex is. What is H and what is K?
3 and 1.
No. If it was 3, then it would say x minus 3. Notice that. X minus H. And I'm looking at an x plus 3. Therefore, what must H be?
-3.
What's K?
-1.
Not negative. That does say plus K.
So just 1.
So just 1. Okay. In other words, here's what I had. I had x minus a minus 3, which turned it into x plus 3 squared. So h is definitely minus 3. This whole thing becomes this whole thing. And the plus 1, k has to be 1. So I immediately know how to graph it based on, well, I know how to graph most of it. I don't know how to graph all of it yet, because the vertex is not the only thing that's important for graphing it. In other words, I know how to graph this much of it. I know that y coordinate is at -3. There's the vertex right there. Okay. And I know that a is positive because it's a 1. In other words, there's no a in front of this, which means there's an implied 1. And since it's positive, it opens up. So I can graph that thing.
Oh, okay.
It's hard to graph if I graph it in that format there. Okay? Now, let's take the one you gave me. The only reason it's harder is bigger numbers. I don't know why they would do that to you, but I mean, when you're trying to learn something, you don't need big numbers to make it harder. It was -16x, right?
Yes. Or -16x squared.
Oh, correct. Sorry. Yeah. We're going to do exactly the same thing, only we have a coefficient now in front of the x squared. And that's problematic because you cannot complete the square until you have it just x squared. Okay? So I started with the same, put the parentheses around that. Now what do I have to do? Because I don't have it just x squared. I got a -16 in front of that.
Divide it by -16.
Yeah, factor out the -16. What's that leave behind? X squared there. What's the rest of it?
96 divided by -16, right?
Well, we've already divided that by -16. Now we got to divide that by -16, which gives us 6. So it's -6x. Leave space to complete the square, plus 3. Now, at this stage is where you want to check to make sure you haven't changed it. In other words, is equation 1 the same as equation 2?
Mm-hmm.
Yes, it is. And this is where you want to check it, because by the time you get done, if you don't have the right answer, you're not going to know where you made your mistake. So I am a huge believer that when you're doing this kind of algebra, you want to check every line. Now, let's complete the square again. In other words, the task, we've got it into a situation where it's x squared all by itself with no coefficient in front of it. You always have to get it to that step. I cannot complete the square when it's like that. You can't do it. Okay? But now I can complete the square inside there. So how do I do it again? What did you do last time? It was the same number.
Oh, with the top one?
No, you take half of the coefficient of the x term.
Oh, yes. So, -3.
Okay, and now square that.
-9.
No, -3 squared is 9.
Oh, yes, that's right.
Always positive. That sign is always going to be a positive sign. It doesn't matter whether this sign is negative or positive. It turns positive by the time you complete the square.
Mm-hmm.
Now, the next question is a little bit more advanced, because what did I just add to the equation when I wrote that +9 in there? I can't arbitrarily add 9 to a function. It changes its value.
Mm-hmm.
So what do I have to do on the same side of the equation?
On the same side.
Mm-hmm. Here's what I had. This, what I'm looking at, is the same thing as what is at the top.
Mm-hmm.
Now, when I add 9, I've just changed it. How have I changed it? What did I just do to that function?
Changed its value.
I subtracted 144. Remember that 9 is being multiplied by a -16.
Ah, yeah.
So the reality is that when I wrote in 9 there, I subtracted 144, 9 times 6, -16, which means I have to add 144. Now it's exactly the same. In other words, if you now analyze equation 2, as I've written it, it's the same as equation 1. That's always the key. Most people, the mistake they make here is they subtract 9. Because they added 9, they subtract 9. But when I wrote in this +9, I didn't add 9 to the equation. I subtracted 144 from it. Because that 9 is being multiplied by -16. Okay. Now, here's what we have. How can I write this term right there? Remember, the whole point of completing the square is so that you can write it as a linear term squared. What linear term is b squared? Just what did you get when you took half of that coefficient?
It's 3.
So it's x -3 squared. Square x -3 in your head, and you'll get this. And it will always be that. In other words, whenever you complete the square, you will be able to write it as a linear term, linear being it's x to the power of 1, minus or plus some number squared. You will always be able to do that. Now, I add those two numbers, and I get 147. There's your answer. Now tell me what the vertex is. Tell me what h and k is. And a. Remember what your format is. It's y equals a times x minus h squared plus k. That's what we're trying to make it look like. Well,
Okay.
it looks exactly like that right now. Equation 3 looks exactly like our vertex format.
Mhm.
Tells us what a, h, and k are. What is a?
Negative 16.
Okay, what is h?
3, right?
Correct. Good. And what is k?
147.
Now I have enough information that I can graph that thing perfectly. Well, I did in the easier one also. But the reason this was the maybe a second order of degree difficulty over the first one that I gave you was having to factor out that coefficient in front of the. Okay. Now, I'm going to give you another problem just to show you that it's not as easy as you might think. Okay, let's take a problem like that.
Okay.
Okay. First thing I'm going to do, put parentheses around the x terms, like that. Now, my intent is to complete the square because I'm trying to make it look like this. Always remember this formula that I'm writing here in the upper left. That's always where you start all these problems.
Okay.
You have to make it look like that. Now remember, you cannot complete the square as long as I have a 2 in front of the x squared. So what's my next step?
To factor it out.
Okay, and this is where it gets a little tricky because notice that 2 is not a factor of 3.
Mhm.
But doesn't matter. Do this. Have I changed it?
No.
No, it's exactly the same, right?
Mhm.
Okay, now let's complete the square in the middle, or inside the parentheses. In other words, I'm now in a position to complete the square. I've eliminated the coefficient in front of the x squared. What's the next step?
To subtract.
Oh, take half of the
Right.
coefficient that's in front of the x term and square it.
Uh-huh.
So what is half of 3 halves? 1/2 times 3 halves. Yeah. Multiply those two fractions. 1/2 times 3 halves.
Just multiply them across.
Yep.
So 3/4.
Okay, now square that.
9 over 16.
Okay. Now, how much did I just add to the right side of the equation when I wrote in there 9 over 16? Did I add 9/16?
No, it's.
What did I add? Okay, you got to be able to multiply fractions.
Yeah,
fractions and whole numbers. So you got to be able to do this multiplication.
18 over 32. I believe.
18 over 16. When you multiply a whole number by a fraction, you just multiply the numerators. That 2 is 2 over 1.
Oh, okay.
So you get 18 over 16. So that's what I added. which means that's what I have to subtract in order to balance it.
Mm-hmm.
Okay? Now, I'm close. I'm just one step away from being able to write it in vertex format. What goes here? In other words, this whole thing can now be written as a linear factor squared. Always. X plus what? I know it's a plus because that's a plus. What was half that coefficient? What was half of this coefficient right here? The coefficient was 3/2. You took half of it. What is it?
3/4.
So it's this. Okay. This is 1 1/8. There's your answer. Tell me what A, H, and K are based on that answer.
A is 2. H is 3/4.
It's always the opposite sign.
Oh, okay. So -3/4.
On the H, it's always the opposite sign.
Okay.
K, it's plus K.
Mm-hmm.
So the K is still 9 7/8.
Okay.
And now with that information, you can graph it and do anything else you want to do. Now, completing the square is used in a lot of instances other than just this. In other words, what I'm doing here is taking a quadratic that's in regular format, that's standard format, and I'm merely converting it to vertex format. And the way you do that is to complete the square. And the reason you do it is because once I have it in vertex format, now I know where the vertex is. Vertex is at -3/4, 9 7/8. And I know the A is just a vertical stretching. So instead of a parabola like this, it would be a parabola more like that. The two would act as makes it skinny. Okay. All right. You have any others? I gave that one to you. Yeah. And the reason I gave it to you, what's different about this one is the fact that you've got to factor that 2 out, whether it factors or not. In other words, it doesn't matter that 2 does not divide into 3 evenly. You still have to get rid of that 2. I've got to do this step right here. Now, sometimes it won't always leave a fraction. In other words, if that would have been a 4, then this would have been 2. But sometimes it does leave a fraction, and you have to deal with that. All right. Do you have any other? The first one you gave me was a pretty hard one. You must have some more difficult ones.
If we could move on to quadratic systems, actually.
Okay.
I've got one here. The system is x squared plus y squared equals 10 is one of the equations.
Okay.
And the other one is y equals -3x plus 10.
What? Y equals what?
-3x plus 10.
Okay. What is that? What are both of them? What do they look like? What is the top one? It's a circle. It's a circle.
Circle.
What's the bottom one?
a y-intercept?
The bottom one's
Or
a straight line. The bottom one's a linear function. In other words, I'm going to graph this as a straight line. I'm going to graph that as a circle.
Okay.
Okay, the circle is the square root of 10. It's a circle that is about the origin at the center. And this radius right here is square root of 10. Now, if I graph that, I know that the y-intercept is at 10, which is about up there. So it goes through that point. It's got a slope of -3, meaning I go down 3 over to the right 1. So I've got something that looks like this. Now, I've just approximated those on my drawing. So I don't know if that line really crosses that circle or not. What if that line does this? And there is no intersection. Okay? So, we're looking at one of these two models. The only thing I know for sure is that this is what I've graphed over here is an approximate solution, but I can't tell if it's a solution or not. I got to go back and do it mathematically. Let's use substitution. Okay?
Okay.
The reason I'm going to use substitution is because I've got one variable fully defined. That y right there. I know that y is -3x plus 10. So I'm going to go back to equation number 1, and I'm going to write x squared plus not y squared -3x plus 10 squared equals 10. In other words, all I did was substitute what y was. Okay. Now, notice what I'm looking at. I'm looking at a quadratic. It's real simple. Now all I got to do is find a solution to that quadratic. Well, first of all, let's square this. Okay, when I square that, I get 9x squared minus 60x plus 100. Have not changed anything. Just started solving the equation. Okay? Now, combine like terms. Take away the parentheses. What do you get?
$69x squared.
Hold on.
Plus 100.
Hold on. You're starting from this point right there, and you're removing the parentheses. That's always the next step in solving any equation. Get rid of your parentheses, get rid of your denominators. We don't have any denominators, so we just got to get rid of those parentheses. And gather your like terms. So I can just, to get rid of the parentheses, because it's preceded by a plus sign, is all I need to do is this. There, I just got rid of my parentheses. Okay? Now gather like terms. How many x squareds do we have?
2.
Total them. Add them up. I got 1x squared here. I got 9x squared there.
10x squared.
Still got minus 60x. I still got 100. Equals 10. Well, I'm just going to bring that 10 over here and make this 90. Let it equal 0. Now I got a quadratic I can work with. Now let me make a little bit of space here. Remember that picture. I'm going to draw that picture again once we've solved it. Because if I can solve this, I've got a solution. That means those two lines do intersect. Okay? Well, how do I solve that? Let's start out by dividing everything by 10. That'll make things a lot easier. So I got x squared minus 6x plus 9 equals 0. Notice that factors rather nicely. Tell me how that factors.
How
do you factor a simple quadratic? That's as simple as it's ever going to get.
Okay.
What's step 1 in factoring? See, the problem is you're trying to do it all in your head in one step. That's not the way you want to factor. Just isn't. Do it by steps. It's the only way I know how to teach anybody how to factor. No matter how many times I teach it, people still come against the quadratic and they want to do the whole thing in their head. They want to figure out what it's x minus something times x plus something or whatever. Don't do it that way. Do it by steps. First step, separate the x's. That has to be true.
Yeah.
What's the second step?
Find the signs.
Okay, what are both signs? Find both signs, not just one sign. Find both signs.
One's minus and one's plus, right?
No, that would never produce a plus 9. In other words, when you are factoring, you're doing the reverse of foiling, right?
Oh, yeah.
Well, when you're foiling, here I'm going to give you the answer. It's minus 3 times minus 3. If I'm foiling those back together, what's my last term? Plus 9. Well, if this was a minus 9, these two signs would have to be opposite.
Right.
So knowing what that sign is tells me a whole lot about factoring. It tells me my signs have to be the same. They don't necessarily have to be plus plus, but they either have to be plus plus or minus minus. And by looking here, that minus tells me they're minus minus.
Okay.
Okay. Now, I got it down to this. Almost done. Tell me what x is.
Oh, x is 3, right?
Yeah. In other words, I've got two things multiplied together that are equal 0. One of them has to be 0. So I set x minus 3 equal to 0, and I solve it. X equals 3. Now, that tells me that I had a solution. There's my circle. And it tells me that solution comes at 3. So that line looks something like that. Where that point is at x equal 3. In fact, y is 1. So x equal 3, y is 1 actually comes right there. So if I wanted to redraw that, here, let me draw the blue line. That's a little more representative. That's the way that thing looks. The blue line is this function. The circle is that function. And I know exactly that that blue line is tangent to the circle. The reason is that I only came up with one solution. If it was this, I would have two solutions. I would have a solution there. I would also have a solution there. So when you come up with precisely one solution, when you're dealing with a straight line and a circle, that means the line is tangent to the circle, because I only came up with one solution. Now, if x is 3, y has to be 1. So y equals 1, and that satisfies both that equation and this equation.
Okay.
Okay. All right. Sounds like you're maybe getting into conic sections. Are you in conic sections? didn't really have to know that this was a circle. So you might not be in conic sections, but that is the equation of a circle. But from an algebraic point of view, I didn't really need to know that. You'll notice that all of my math did not depend on me knowing that that was a circle. Because all I did was substitute.
Right.
For the y in the equation 1, I substituted minus 3x plus 10 to get this. Now I solve it, and when I solve it, I get x equal 3. Well, if x equal 3, and you plug that back in, you can get a y equal 1. So there's our only solution. And the fact that we only have one solution, if I happen to know that that's a circle, then I know that that solution, that straight line, is tangent to that circle. But you don't really need to know that. In other words, you don't need to know that it's tangent. You just need to know the solution. And the solution is x equal 3, y equal 1. And that does satisfy both of those equations. X equal 3, y equal 1. What else we got, Jameson?
A system of equations if one equation is quadratic.
Okay, that's basically what we just did. We had one equation was quadratic and the other was not. So give me the two equations again.
Okay, y equals 2x plus 8. And y equals x squared plus 2x, or 12x, plus 32.
Plus 32?
Yes.
Okay, now I don't know if it's helpful or not, but I know quadratics are parabolas, right?
Mm-hmm.
Okay, so I'm probably looking at something that looks like that. That blue is a straight line, so probably looking at something like that. In other words, I'm going to have two solutions unless this blue line is precisely tangent, in which case I would only have one solution. But again, I don't really need to know any of this over here. I just have to look at this as an algebra problem that I can solve.
Mm-hmm.
Well, if y equals this and y equals that, then what equals what?
Oh, 2x
same
plus
lines.
8.
Yeah, exactly. In other words, I'm going to do it like this just because it's going to unfold a little prettier if we leave that x squared on the left side. But right off the get-go, I can do this. Okay, you with me?
Mm-hmm. Yeah.
Now set it up like a normal quadratic. Get everything on one side, 0 on the other.
Okay, can we start off with minus 8?
No, we're going to put everything on the left side because we already have a positive coefficient in front of that x squared. So whatever you find on the right side, move it to the left side. Because we always want 0 on one side when we're trying to solve a quadratic.
Okay.
So I'm going to subtract 2x from both sides, and I'm going to subtract 8 from both sides.
Mm-hmm.
That's going to give me x squared plus 10x plus 24.
Okay.
Okay, I haven't changed anything. I've just rearranged it and gathered like terms.
Mm-hmm.
Back to that. And the solution will be obvious after we factor it. Factor it step by step.
Okay. So the first, the variables are both x. And
Step 2.
the signs are both plus.
Step 3. Verbalize step 3 for me. I want
Okay.
factors of 24 that do what?
Multiply with 10, or add to 10.
Add the 10. They add the
Yeah.
this right there. If that was a negative sign, then they would subtract the 10.
Mm-hmm.
But it's not. It's a positive sign. So we're looking for factors of 24 that add to 10. What would that be?
Okay.
If you don't know right off the get-go, then factor it.
Oh, it's
all factors.
It's 4 and 6. Yeah.
Yeah, 4 and 6.
Mm-hmm.
Those are factors that add to 10. So what are my two answers?
X equals -6 and x equals -4.
And you'll notice that each one of those produce a different y.
Mm-hmm.
When x equals -6, y equals -4. And when x equals -4, y equals 0. So your solutions are the following. You have -6, -4. That's one point. The other one is -4, 0. So my parabola, I now know what that picture looks like a little bit better. I know that it's going to cross at -6 here. Let me erase a little bit more here. All right, so if I go to -6, -4, that's about right there. That's an intersection point. And if I go to -4, 0, that's an intersection. Whoops, hold it. -4, 0 is right there. Let me erase this one. Really going to confuse you. So my parabola and my straight line, well, my straight line looks to be this. And the parabola is going to do something like this. Notice that my straight line crosses my parabola in 2 points. What are those 2 points? That's one of them. That's the other.
Mm-hmm.
So when you're solving a system of equations involving one linear and one quadratic, you almost always are going to have 2 solutions.
Okay.
The only time you would not have 2 solutions is if this straight line was exactly tangent, like that. Remember the last problem? It was exactly tangent to the circle, and we only had one solution, which was x equal 3. But this case, that straight line is inside the parabola, and it crosses it there and there.
Right.
Which are there and there.
Mm-hmm.
Okay. What else?
I actually don't have anything else right now.
Okay. That's fine. We can. We don't need to go to 5:30 if you don't have anything else.
Yeah.
But that should be. It's not necessarily that you have to be able to see it graphically.
Mm-hmm.
In other words, both of those problems that you gave me, I was able to solve algebraically. I didn't have to know one was a circle and one was a straight line. And then the next one, I didn't really have to know that one was a quadratic, a parabola, and one was a straight line. I didn't have to know any of that. I just had to use the method of substitution and solve it. That's all I had to know. I didn't have to know any of those geometric shapes. Just had to be able to solve it algebraically.
Mm-hmm.
And usually it comes down to a quadratic that you have to factor. So you'll notice that both problems we had to factor it.
Right.
All right. Jameson, I'm going to let you go if you don't have any other questions.
All right. I don't think I do.
Okay. Have a good evening.
You too. Thank you.
Bye-bye.
Bye.